Among the countless worlds in our solar system, one moon burns brighter quite literally than the rest. This is Io, Jupiter's volcanic moon. Imagine a world where the ground itself heaves under tidal forces, where rivers of lava carve the land and sulfur paints the surface in alien colours. Today, on Cosmic Compass, let's journey to this restless world, explore why it is the most geologically active body we know, and uncover the strange relationship it shares with its giant parent Jupiter. Buckle up, this is a trip into fire and fury on a cosmic scale. Among all the moons in our solar system, one stands out as both violent and mesmerising. This is Io, the innermost of Jupiter's large Galilean moons, a world of fire surrounded by ice. Unlike the icy Europa or Ganymede, Io is a place dominated by extreme volcanism, where sulfur paints the surface in yellows and reds, where towering lava plumes erupt hundreds of kilometres high, and where Jupiter looms in the sky nearly 40 times larger than our own moon. Welcome back to Cosmic Compass. Today we're going to explore Io, its orbit, its fiery surface, its explosive volcanoes, and even how it interacts with Jupiter's immense magnetic field. Io may well be the most geologically active place in the entire solar system, and by the end of this journey, you'll understand why. To appreciate Io, let's place it in context. Jupiter is home to at least 79 moons, but 4 of them dominate, known as the Galilean moons after Galileo, who discovered them in 1610. They are Io, Europa, Ganymede, and Callisto. Io is the closest of the 4, orbiting just 350,000 kilometres above Jupiter's cloud tops. That's close enough that from Io's surface, Jupiter would appear 39 times larger in the sky than our moon does from Earth. Imagine looking up and seeing a gas giant filling almost your entire horizon, an awe-inspiring and intimidating view. Io completes one orbit of Jupiter in just 42.5 hours. Even more fascinating, its orbit is in resonance with Europa and Ganymede. For every orbit, Europa makes Io circles twice. For every orbit of Ganymede, Io completes 4. These orbital resonances constantly target Io, preventing its orbit from becoming perfectly circular. This slightly eccentric orbit means Io is constantly stretched and squeezed by Jupiter's immense gravity, a process called tidal heating. At times, the solid ground of Io bulges up and down by as much as 100 meters. To put that in perspective, Earth's oceans rise and fall by only a few meters due to the moon's pull. On Io, it is not the water that moves, it's the rock itself. This tidal heating is the engine that powers Io's extraordinary geology, fueling the volcanoes that make it unique among all worlds we know. Io is not the largest Galilean moon. It is actually the second smallest, larger only than Europa. Yet, in many ways, it is the most Earth-like of the group. Its diameter is similar to our moon's, and its surface gravity is comparable. But there is a crucial difference. Io has the highest density of any moon in the solar system, where Ganymede and Callisto are mostly ice mixed with rock. Io is almost entirely rock and metal. Its composition resembles the terrestrial planets more than the icy moons. Beneath its thin crust lies a mantle rich in silicate material, and at its heart, scientists believe there is a metallic core of iron or iron sulfide. Unlike Earth, however, Io does not appear to have an active magnetic field, suggesting its core does not convect the way Earth's does. Instead, its mantle is partly molten heated by the relentless tidal forces we just described. This is the reservoir from which Io's spectacular volcanic activity is born. It is also worth noting what Io lacks water. In fact, Io has less water than any other known body in the solar system. In a system dominated by icy moons, Io is the outlier, a bone-dry world consumed by fire. For much of history, Io was just a small dot seen through telescopes. Astronomers speculated it might be coated in sulfur, but there was little certainty. That changed in the 1970s when NASA's Pioneer 10 and 11 spacecraft flew past Jupiter. Pioneer revealed that Io was a rocky world with a thin atmosphere, not an icy body, but the data were limited. Jupiter's intense radiation interfered with instruments at times bombarding the spacecraft with levels thousands of times stronger than Earth's radiation environment. The real breakthrough came in 1979 when Voyager 1 and 2 arrived. Voyager 1, passing within 20,000 kilometres, sent back astonishing images. Instead of a cratered surface, Voyager revealed a colourful world dotted with mountains higher than Everest, vast lava plains, and active volcanic plumes erupting into space. For the first time in history, humanity had direct evidence of volcanic activity beyond Earth. Io was alive. Voyager also confirmed that Io's surface was coated in sulfur and sulfur dioxide frost, giving it vivid yellows, whites and reds. In just a few flybys, Io transformed from an obscure moon to a world of intense scientific fascination. The Galileo spacecraft arriving in 1995 gave us even more detail. Despite technical issues, Galileo captured some of the highest resolution images of Io's surface, confirming lava flows of silicate magma rich in magnesium similar to Earth's basalt, but often far hotter. It observed ongoing eruptions reshaping Io in real time. Later, in 2007, New Horizons passed Jupiter on its way to Pluto and turned its instruments toward Io. By sheer luck, it caught the volcano Tvashtar mid-eruption, spewing a fountain of lava hundreds of kilometres into space. For many, this was one of the most spectacular volcanic displays ever recorded in the solar system. Step by step, each mission revealed more of Io's fiery nature, painting a picture of a world in constant turmoil. Let's now explore what makes Io so unforgettable: its volcanoes. Io is the most volcanically active body in the solar system, with hundreds of active volcanoes across its surface. The colours are extraordinary. Plains of yellow sulphur dominate, while white regions are sulphur dioxide frost. Reds and oranges mark areas where volcanic deposits have settled or where radiation has altered the surface chemistry. From space, Io looks like a swirling canvas of sulphur and fire. Among its most famous volcanoes is Pele, which leaves behind a vast red ring of deposits stretching thousands of kilometres. Loki, the largest lava lake in the solar system, is a depression 200 kilometres across. Sometimes its crust collapses into the molten interior, releasing 10 times more heat than usual, making Loki responsible for about a quarter of Io's total thermal output. And then there is Tvashtar, whose eruption was captured in dazzling detail by New Horizons. Imagine standing on Io and seeing a lava fountain blasting so high it could cover the state of Alaska. These eruptions are not rare. They are part of Io's normal cycle, driven by the relentless flexing of its interior. Io also hosts mountains, unlike any on Earth. Some rise 18 kilometres tall, taller than any peak in our solar system. Strangely, they are often isolated, not part of ranges like Earth's mountains. Lava lakes are sometimes found nearby, suggesting that tectonic stresses and volcanic activity are linked. In short, Io's surface is a constantly shifting landscape of lava, sulphur, and towering peaks, a true hellscape sculpted by gravity and heat. Io's uniqueness doesn't end with volcanism. It also plays a key role in shaping Jupiter's vast magnetosphere. As Io erupts, sulphur, oxygen, and other particles escape into space, forming a vast neutral cloud along its orbit. These particles are quickly ionized by Jupiter's magnetic environment, feeding into what is called the Io plasma torus, a giant ring of charged particles that encircles Jupiter. This plasma torus spins much faster than Io itself, at about 70 kilometers per second, compared to Io's orbital speed of 17 kilometers per second. As the torus interacts with Io, about 1 ton of material is stripped away from the Moon every second, continuously fueling Jupiter's magnetosphere. The interaction doesn't stop there. Magnetic field lines connect Io directly to Jupiter's poles, creating what scientists call the Io flux tube. Through this channel, electrical currents flow between Io and Jupiter, sparking powerful auroras in Jupiter's atmosphere, exactly where Io's magnetic footprint touches down. Remarkably, Io itself also glows with auroras. Unlike Earth, where auroras are confined to the poles, Ios are scattered across its surface. Green comes from sodium, red from oxygen, and blue from sulfur. These glowing patterns are a visible reminder of Io's constant exchange of energy with its parent planet. Io is not just shaped by Jupiter, it is actively shaping Jupiter's magnetic environment, making their relationship one of the most fascinating in planetary science. Io is unlike any other world we've discovered. It is a place of extremes, the driest known body in the solar system, yet the most volcanically active. A moon whose mountains rival the tallest in the solar system. A world that glows with auroras, while feeding the magnetosphere of the largest planet. By studying Io, we learn not only about this fiery moon, but also about the power of tidal heating, the nature of planetary geology, and the interplay of matter and magnetic fields on a grand scale. Io reminds us that moons are not just passive companions to planets, they can be dynamic worlds in their own right, reshaping themselves in dramatic fashion. So next time you look up at Jupiter through a telescope, remember that orbiting close to its clouds is a world of fire, constantly erupting, constantly changing, and constantly amazing us Io, the volcanic heart of the solar system. Io is a reminder that the solar system is not static, it is alive, dynamic, and at times violent. By studying Io, we not only witness the extremes of geology, but also learn how gravity, heat, and magnetism shape entire worlds. If you enjoyed this journey through Jupiter's volcanic moon, be sure to subscribe to Cosmic Compass, where we explore the hidden stories of the cosmos together. Share this with a friend who loves space, and let us know in the comments if you could stand on Io for just a minute. What would you look at first, Jupiter looming above, or the fiery volcanoes erupting at your feet? Until next time, keep your eyes on the stars.